Hello everyone, welcome back again to the course on Artificial Intelligence in Industrial and Management Engineering. We were learning about natural language processing and we will continue today by understanding the other foundational blocks of language. So, we have covered morphemes and lexemes. The next is the syntax of the language. So, syntax is nothing but a set of rules to construct grammatically correct sentences, right? Now, syntactic structure is guided by a set of grammatical rules. Common approach is to develop a parse tree. So, what is this parse tree? Parsing is the construction of trees from sentences in an automated manner. So, parsing is a process, right? And by following this process, the machines will develop a complete hierarchical structure of a single sentence, like from the topmost thing, like the noun or the subject, and then going downwards towards each and every aspect of the sentence, right? So, different languages will have very different structures, right? And thus processing of parsing is language specific. The last thing, this basics of language is context. So, context is composed of semantics and pragmatics. So, we can usually know that meaning of a sentence changes based on the context. Right? So, what is semantics? It is the direct meaning of words without external context. And pragmatics is adding world knowledge and the external context of conversation. So where we utilize this context is in our current natural language processing algorithms is the summarization task uses context extraction heavily. Okay. Now these are the few foundational blocks of a language. Now we will study what are the different kinds of toolkits that are available in Python ecosystem for conducting our natural language processing, right. So the first is Spacey. This is a library in Python for efficient NLP tasks. This is open source. It handles, it contains state of the art algorithms for NLP. However, usually we don't have alternatives to choose the algorithm in Spacey library. So what do we mean here is that let's say you have an NLP task and you want to perform it by utilizing the Python ecosystem. Now what Spacey does is it identifies the state of the art algorithms and implements it in its own library, but they do not provide other algorithms to try or experiment with other algorithms, right. So that is why whatever you will get in Spacey library, it will be the best, but you cannot tweak it with other algorithms. So another famous and foundational library is NLTK. This is also another popular library in open source. Provides many functionalities but are often contains less efficient implementations. So Spacey is much better in handling NLP task as compared to NLTK. But NLTK contains various algorithms that you can utilize, and it has very old algorithms as well. So you can install Spacey by writing the command pip install Spacey, and with this installation you also need to download language models, pre-built language models, by utilizing the command python m Spacey. download, and the name of the model that you want to download. Usually, let's say you want to download a small model, so en core web sm, these are some of one of the model that is provided by Spacey for your modeling task. So sm means this is a small model. So let us now look at the overview of the key steps of modeling your corpus of data by utilizing Spacey. So these are the things that we will follow when we will try to develop our own models on the corpus of data during our coding lectures. So we will first load the language model. Then we will build the pipeline object. Then we will use tokens. So tokens will get developed from your data. After that we will, let's say, do parts of speech tagging. And then finally we understand the token attributes. So now since we have this tokenization step, let us now understand what is tokenization. So it is nothing but the process of breaking raw text into component pieces. Okay, so let's say whatever be your simple sentence, the original text will be segregated on, let's say, first it will get splitted on white space, then on prefix, then on exceptions, then suffix, then maybe some more exceptions are still relevant that are available, and finally this will complete the process of tokenization. So let's say this is a lecture. So in this sentence, the while performing tokenization, first we will segregate the complete sentence by utilizing these white spaces. Okay, after that we will perform the segregation on exception, suffix, prefix. Okay, so tokens are nothing but the piece of original text. So what do we mean here is that while tokenization, we do not generate anything new. Whatever we have in our corpus of data, we are dividing it into basic building pieces. So when you are using Spacey, you create doc object, right? So the basic blocks of the doc object in Spacey contains everything that is derived from tokens and their relationship with each other. Okay, so prefix are nothing but characters at the beginning, suffix are characters at the end, infix is characters in between. Okay, and what are exceptions? These are the special case rule to split a string into several tokens. Now let us talk about another task, that is stemming. So we usually utilize NLTK for stemming. In stemming we identify the stems of different words. So let's say searching boats will return boat, boating, which are all but the stem is boat. So all different variation of boat will be revealed when we search boats or something like that. Okay, now the next thing is part of speech tagging. So these are the assignment of different grammatical categories like noun, verb, adjective. So what machine is doing at this stage is it will get a sentence, find all the different grammatical categories like noun, what is the noun in the sentence, what is the verb, what is the adjective, and all other things. Okay, so these kind of identification will help machine understand how each word in a sentence is connected with another word and what is the characteristics of that word in a particular sentence. So let's say she eats an apple. Okay, so here it is a pronoun and it is eats is a verb and apple is a noun. So this way the machine will start telling you what is the actual grammatical category in the sentence. Other task is named entity recognition. So it identifies entities like people, location, organization, etc. in a sentence. So let's say as an example, Google was founded in California. So here we can identify that Google is an organization, right? And California is a location. So these kind of tags gets identified automatically by the machine here, and these are very useful information for any kind of automated machine learning task. Another task is parsing, and here we understand the dependency or the sentence structure via dependency trees. So these are hierarchical trees. We have already talked about these parsing task. Another useful task in the natural language processing is lemmatization, and what it does is it applies morphological analysis to words. So let's say you are writing was, so the actual root is B, or you are writing mice, so the actual word is mouse. So these kind of identification can be done by utilizing the lemmatization task. So lemma is much more informative than simple stemming, right? So under the process of stemming we are only identifying the stem of the word, but here we are identifying what is the actual word and what is the root of that word. So this is useful, and Spacey provides lemmatization only. Lemmatization also detects part of speech using surrounding words. Okay, so we can stop here, and we will try to implement all of these basic foundational building blocks of natural language processing in our coding session, and we will also implement an applied area of natural language processing, that is text classification, by utilizing a large data set of around 2000 or 5000 feedbacks from the users, and then we will try to classify what are the different insights that we can get from this kind of data set. Thank you.